Okay, so this is lab 2, and lab 1, I'm going to pull up this visual chart here. It's not this one, it's actually this one. And I'll expand it. In lab 1, we created the virtual private cloud, as you recall, which resides in the Amazon infrastructure. And within that virtual private cloud, which has a parent IP address of 172.16.0.0/16, we created 2 availability zones, right? An availability zone A in the US East 1A region, and an availability zone B in the US East 1B region, right? Under the Northern Virginia region. And so in the first availability zone, we signed 2 subnets, a public and a private. And we did the same thing for availability zone B. We assigned a public and a private using the 172.16. And then we used the third octet to designate our network, and the third octets are unique. So 1 and 3, which is the odd number, and the third octet represent the public subnets, and the 2 and 4 in the third octet, which are even numbers, represent the private subnets. Okay, so we're going to pick up where we left off, and we're going to add on to the topology. What we're going to do today is create an Amazon Linux EC2 instance in the public subnet 1 in availability zone A. Okay, we're just going to do this one from this lab today. In a future lab, we're going to create an image from this instance that we create. And then instead of going through the 50 steps of creating an EC2 in availability zone B, we'll have an existing image, and we'll just use that image, and everything we configured on that EC2 will apply to the second instance in availability zone B on public subnet 2. Okay, so couple things, right? What is an EC2 instance? It's a virtual server, right? Servers can be used for a lot of services on a network: file storage, email servers, web servers, etc. So in this lab, we're going to set up a web server. And what is Amazon Linux, right? Well, Linux is an open source operating system. And what I mean by open source is that the source code is available to the general public at large, and you're free. Scientists and engineers are free to modify the source code as they see fit, which is different than a proprietary operating system like Windows or the Mac OS, right? Those are proprietary, and those source codes aren't available. The blueprints, so to speak, aren't available to the general public. Okay, so we're working with an open source operating system. And again, we want to keep the costs low, and everything is free tier as much as possible. So you'll be using Amazon's version of Linux, and the EC2 is a virtual server. Once we create the virtual server, right, we'll also set the server up to be a web server as well, so to host websites. Okay, we'll go ahead and get started, and I'll walk you through the steps of the lab. Okay, the first, I'm going to minimize this window, and I'm going to minimize my documents folder. And from here, you are going to log into the AWS Academy Learner Lab, which is located underneath the AWS Academy Learner Lab. So you'll see a link here that says Launch AWS Academy Learner Lab. You want to click on it. And again, it's going to take a while for the lab to load. Before we actually get started with the lab, we're going to make sure our existing environment that we did from the last lab is in there. You can see my cost, right? So it looks like I've used 10 cents, right, out of $50. So the goal is to keep the costs as low as possible. And we'll take advantage of free tier services as much as possible as we go through this infrastructure. Okay. And from here, we'll just click on the Start Lab button. And while that light is amber, we got to wait for it to go, it's yellow, we got to wait for it to go green. Okay, I will pause the video because it's going to take a couple of minutes for it to load. And once it completely loads, I'll jump back in. Okay, actually, it didn't take long. I must have been offline like 10 or 15 seconds and the light came green. So when you see the green light under AWS, you're going to want to click on it. Okay. And what we want to do is verify our existing configuration that we did from last lab, right? All that information about the VPC should be in there. So make sure we're in the North Virginia region, okay? And from here, we are going to go to the Services tab. I'm going to do it the long way, just so you could see all the services that are available. Now I'm going to scroll down to Networking and Content Delivery. I'm going to click on it. And I'm going to click on VPC at the very bottom. Okay, and as you see, right, I want to click on this VPC tab link here, or I can click here where it says your VPC. So I'll click on your VPCs. And what we want to take note of, we want to remember the name of our VPC. Okay, so the name of the VPC, I created, and you probably gave it the same name. If not, that's okay. Just remember the name. It's lab-VPC, right? And recall the VPC ID, right? It ends in EA5. So we want to keep that number, right? Our VPC ends in 5, not in 6, because that's the default VPC. And we can see the CEDAR block, IPv4, parent IP address that we assigned to it. And from here, real briefly, we want to make sure that's available. The tenancy is set to default, which means with virtualization, resources could be shared on the same physical hard drive as a different organization. Okay, and if you recall, we had the resource map. Okay, and we had our subnets assigned. So if we click on subnets, okay, we got the US East 1A and the US East 1B, right? The public and private subnets and a public and 1A. So if we go to the public ones first, right? 1A, which is in the first availability zone A, and we go to the second public subnet in 1B, which is the second availability zone 1B, you could see that the addresses for those are odd numbers, right? So you just want to verify that. And then the private subnets in the two availability zones, 1A and 1B, are even numbers. Okay, now I'm going to see if it'll clear out these subnets. I don't want to spend too much time on how to clear things out. I could do that in the very last lab, but I'll highlight all the subnets that are not in use, right? Make sure you check off your subnets are not checked. So I don't have check marks here. And from the actions menu, I select delete subnet. Okay. And it may ask me to confirm delete. I may have to manually type that in, delete, and then hit delete again. Okay. And then they're gone. Okay. It'll be a lot easier to look at in the future. Okay, so we've got rid of our subnets. And from here, we've got our existing route tables. And we'll leave that as is. And we have an existing internet gateway that we went over in the last lab. We don't have a NAT gateway set up yet. And so we're going to get started with create an EC2 in this virtual private cloud. So we're going to click on the services menu and we're going to select compute. And then we're going to select EC2. Okay, now I'm going to pull up the instructions. And I can keep everything in my documents folder. And then as you can see, as I'm building these labs out, let me find I think it's this one, curriculum development. No, that ain't it. Okay. AWS Labs for courses, my bad. So we double click this folder. This is a NETC course, instructor created labs. Okay, and I'm pull up the instructions with how to create an EC2 instance, and I'll use the PDF version. Okay, and we've already done step one, right? So, and I'll be talking our way through these steps. So we're going to select the launch instance button in the middle of the page. Okay, and we'll give the instance a name of web server 1. I'm actually going to highlight that now and copy it. And then I'm going to return to our browser tab. And so in the middle of the page, I'm going to select launch instance. Okay, and so in the name and tags box, so we're going to give it a name called just web server 1. Okay, now we scroll down to application and OIs, right? The OS images. So what we want to look for is we want to look for the Amazon Linux, which is normally selected by default, right? Ubuntu is a Linux-based operating system, which is also open source as well. But you have some proprietary operating systems like Mac OS and Windows, and Linux, Red Hat, yes, and some other Linux-based operating system. But we're just going to leave it on Amazon Linux. Okay, and what we want to do is choose an AMI that's free tier eligible. Okay, there are some AMI or operating system images that are not free tier eligible, and I'll give you an example of one. I saw one here with the NVIDIA drivers. So NVIDIA is a high-end processor. I mean, they're one of the best uh, processing chips manufacturers on the planet. You probably heard of them. So high intensive gaming programs and artificial intelligence programs that are high graphics intensive utilize NVIDIA drivers. So those aren't free tier, right? We're not going to get those. We're going to choose the free tier eligible Amazon 2023 AMI. All right. And we're just going to leave that as is. Okay. And we'll leave the 64-bit architecture as is. Now, for the instance type, right, this is the hardware that's going to be virtualized inside our EC2. So you got to remember, it's virtual, right? It's not a physical hard drive we're choosing. It's a virtual hard drive. And so you look at the capacity, right? One CPU, 1 GB of memory, which should be fine for the type of website we're going to launch. Okay, the Nano instance is not free tier eligible, so there's only one free tier eligible. But as you see, right, like if you select T3 large, there's 4 central processing units, and you got 16 gigabytes of memory right here. So we're going to just choose the T2 micro that is free tier eligible. Okay, now when you access a machine or EC2 instance remotely, right, over the internet, you want that connection to be encrypted, right? And so you don't want a session in which you remotely connect to a EC2 instance or a virtual server, right, that's in clear text. So we want to use what's called secure shell if we were to log into an EC2 remotely. For the purposes of this lab, we're not going to do it, but we need to create a key pair because that's how it would be done in the real world. You're going to select create new key pair, and it's pretty simple. And we'll call the create key pair Vockey, Vockey. Okay, it may already exist because of a previous lab. So if you see that, put a 1 after it, and you'll be Vockey 1, right? And we want to leave the private key file format as .pem for OpenSSH, okay? Or PPK if you want to use PuTTY. So you can log in remotely using PuTTY or using the OpenSSH format, okay? If you're familiar with the Cisco class, you might have used PuTTY before because you need PuTTY to access the routers and switches remotely as well. So we're just going to select create a key pair. And what that does is it downloads it to your downloads folder. Okay. And from there, we are going to go to the network settings. Okay. Now here's where we want to make sure we edit our network settings. So if you're following along on the lab, where is my PDF? Okay, we've done step 6, right? 7, and we choose an instance type, and we've done that. We choose the T2 micro, and we created a key pair called Locky1. Okay, in the network settings, we're now on step 15. We're going to edit the network settings, and we want to make sure we choose the VPC in which this EC2 server is going to reside in that we created from the last lab. So again, right, if I pull up the diagram, right, we want to create an I can't pronounce it, EC2 server within the VPC, right? This is the VPC we created in the last lab, right? And we're also going to make sure we place that EC2 in availability zone A under the public subnet 172.16.1.0, right, when we're prompted for that. So we're going to click edit on the network settings. Now remember, you don't select your default VPC. You click the drop-down arrow and select your lab VPC. There's 2 ways you can verify. You can verify it by name, and you notice the 5 at the end. It says EA5, right? Now the subnet, it's very important. What subnet are you going to put it in? Okay, so notice by default, it's putting it in a 172.16.2.0. Okay, we don't want it there. Okay, obviously, because that's his private subnet right here, right? Remember, the odd numbers and the even numbers in the third octet is the private subnet, and we'll put our databases in there. We want to select 172.16.1.0, the public subnet. So we're going to click the drop-down arrow, and we are going to find that public subnet, which is 1.0 here, was at the bottom. So make sure your subnetted address reads 172.16.1.0/24, and it should be in the public-US East-1A subnet. Auto-assign public IP. Okay, so there's 2 ways you can get public IP addresses assigned to your EC2 instance. Okay, now there's options. You can assign a public IP address to a load balancer and then actually place your EC2 instances in a private subnet. And I'll explain more about that later, last lab. Or in our case, our EC2 servers could have public subnets because they're in public IP addresses because they're in public subnets. Okay. Now the 2 ways you can get a public IP is auto assign, and the other way is called the elastic IP. Okay. Elastic IP is the more expensive type because that's more of a permanent type of public IP that you get. Okay. And public IPs are something you have to pay for. Okay, it's just the same thing, and I talked about this on the last lab. Same thing going on in your home network, on your home router. Your home router has a public IP side to it. That's what you're paying for. Okay, and on the inside you have private IP addresses. But if you choose Elastic IP for public, then that's more of a permanent address. And whether you shut the EC2 server down or not, you're going to incur recurring charges because you have a permanent address that kind of sticks with you. Okay. Now, auto assign public IP is kind of like a DHCP server in which you get an IP address from a pool of public IPs. And then when you turn your computer or laptop or EC2 server off, that IP address is released back into the pool. So that's something we want for the purposes of this lab. So we don't incur additional charges while our EC2 instances are shut down. So for auto-assigned public IP, we're going to choose Enable. Okay. And now we're going to create a security group. Security group is a list of rules. It's kind of like a firewall. The neat thing about security groups is once you create one and give it a name, you could apply to several resources in your Amazon infrastructure. So if I create a security group for the web servers and I only allow incoming HTTP, which is web traffic, or HTTPS to come through, and I pretty much block anything else, and I give that security group a name, I can have several web servers. And when I'm adding web servers to my infrastructure, I can choose an existing security group, right? Because it's the same set of rules that apply to like resources. So I'm going to choose create. Okay. I think the instructions may say to, I don't know why I clicked on my email. Okay. So if we go back to the instructions, okay, we got auto assign public IP, and it says to keep the default security group option chosen. Okay, so we want to make sure we're going to create one, and we're going to configure a new security group, and we're going to give it the name web server. Okay, I would have been more descriptive with the name, so since we can, you could type web server security group or security group for web servers. Okay, and then the description, you know what? I'm just going to copy and paste it. Okay, and so you got a security group name, you got a description for it. Now, notice the only kind of traffic it's allowing. So I believe in this lab, which I copied from the Amazon documentation, they wanted you to leave it as is for now. Okay. They want us to remove the SSH inbound rule, which is fine. We can do that and just go on to the next session, which is fine. We're going to have to go back and edit the security group, though, to allow HTTP traffic, because right now we wouldn't be allowing anything to go through. Okay, so we click remove. Okay, and we'll leave that as is. You got an advanced network configuration. We won't do nothing with that. You can close that. And now we go to configure storage. So we're going to choose the free tier eligible. We can get up to 30 gigabytes of storage of EBS, general purpose, SSD, or magnetic. And we're talking about the top type of hard drives. Okay, and so right now we're just going to keep it at the root volume. And without getting too complicated, I'll keep this brief, but a root volume, Linux allows you to create separate volumes. The root volume would be where your operating system is kept. And then you could use additional volumes for like file storage. So you could segment the operating system from the files. I mean, Cisco does it the same way, right? The operating system on Cisco is kept in flash memory, while the configuration file that you type is kept in non-volatile random access memory, or NVRAM. Okay, so you could do the same with Linux, but we don't have to do that for the purpose of this lab. You can create a root volume and add content to it, no problem, okay, which is the default. And I'll pull up the lab instructions. You can read about that in your lab instructions, okay? And so what the free tier root volume will run on a general purpose SSD GP2 hard drive that's 8 gigabit in size, okay? Hard drives are not my expertise, they're not my thing, but right, you get the size of the hard drive. And those of you who are familiar, well versed in A+, you probably know what SSD and all that means, okay? You could add more storage volumes, as I noted, but it's not needed in this lab. And then we're going to go to task 7, which is the advanced details. Okay, so we're good in configure storage. We click on advanced details. Okay, and for now, there's an IAM instance profile. And for now, we'll just leave it at lab instance profile. Okay. And then we want to scroll down to the very bottom here. Okay, right here under user data optional, we're going to put a script. So when the EC2 instance launches, every time it will go through this script, we're going to kind of change or modify the boot process on what services get turned on. And so there was a little script that was created, and I'll explain it. But what you're going to do is highlight this script, right? You're going to right click, select copy, minimize the window, and you're going to right click and select this plain text. Okay, and I'll explain this in a bit what this script does every time you reboot or turn on your EC2 instance. Okay, that the hash bin bash is just a comment, right? Anything beginning with a hash or a pound symbol or whatever you call it is just simply a comment, and it's ignored by the script. It's used for informational purposes for the people who are writing the script and the people who are reading the script. Okay, that's ignored. The first command is yum space update space -y, which means go out and do an update of the operating system every time, right? Check for updates. Okay, and then from here, you're going to install the HTTP, which is the Apache web server. You need a web server software to host a website. Okay, so yum space -y space install space HTTP installs the Apache web server. The system control enable HTTP, right? That enables the Apache web server, and the system control start HTTP starts the Apache web server. Okay, and then there's a command here called echo, right? And echo is a useful means of redirecting output to the monitor screen, but instead of redirecting output to the monitor screen like this HTML web page script, this greater than symbol says don't redirect it to the monitor screen, redirect the contents or the output of that to a file. Okay, and this is the default file in which the main web page are hosted on an Apache web server, right? The root volume, which is a /, the parent folder var, and then there's a subfolder called www, and there's a subfolder called HTML. And within the HTML folder, there's a file called index.html. It's the main page of the website, okay? And so the website content is just going to have a little saying here that says hello world, all right? And from here, we're going to select launch instance. And you should get a successfully initiated launch of instance, okay? Let's go back to our instructions. And we're going to check the status of our instance. So we're kind of like on step 27 right now, right? The instance is going to be a pending state. And so it takes a couple of minutes for the instance to load. Now, there's two ways you can view the instances, right? Obviously, up here, if you click the hamburger, you can click on instances here as well. So you click on instances. Okay, notice you got your web server and your status check is initializing. What you want to verify before we proceed further is that our status checks have passed. Okay, and the instance state remains at running, and then we get a 2 out of 2 from the status checks. Okay, now notice we've been given a public IP. So if you take the check mark off, put the check mark back on it, and you get a bunch of information in the second window below. I'm going to see if I can scroll. It won't let me scroll up. If you click details, you notice it has a public IP, right? You have a public IP right here. Instance also has a private IP. Why does it have a private IP? Think about it, right? Kind of like has a private IP, so it can communicate internally with other devices in the same VPC. Remember, there's a route table that says 172. Remember in the last lab, 172.16.0.0 local, right? It means you can communicate with any of your devices in the VPC. So that just allows internal communication between the private and public subnets in both availability zones. So it does have a private. Okay, I'll minimize that. You also have a public IPv4 DNS, right? Now you could use Amazon Route 53 to create a more unique, user-friendly DNS name. But you know what I mean by DNS, right? www.facebook.com, right? x.com, instagram.com. So this is our DNS name for our EC2 instance. Okay, so it's still running. It's going to take a while for the status checks to complete. Oh, there they go. So they passed. Okay. Now, probably what they're going to want us to do, probably going to want us to test the website, right? And it's not going to work because we're not allowing anything in from our security group. Okay. So security groups, access control lists, if you're familiar with Cisco, same rule applies. It's called an implicit deny. If there's no rule to allow something in or deny something, then it simply won't let something in. It just drops the packets, right? Because there's no rule for it. So right now, our security group is not allowing any traffic in. We can verify that. So if we go back to the instructions and we say it has a public IP, okay, the status checks have passed. Okay, they want us to, we're on step 30 right now, copy the public IPv4 address. So it's right here, not the private, the public. Click on it. And that copies it, right? You get that little notice. And then they probably want to open up a browser tab, new tab, go right click and paste it in. And we shouldn't be able to access it. It's just going to spin for quite some time without any access. So what they probably want us to do is to go back to that security group. Okay, so, and it explains why you can't access it. So from here, we want to, we're on step 32, the web page didn't load. We want to update the security group. So step 33, you're not able to access your web server because the security group's not permitting inbound traffic, right? So we got to update the security group. So we're going to go back to the EC2 Management Council browser tab, and we're going to go to the left navigation pane, network and security, and choose security groups. So that's step 35. Okay, so we're going to go click on our instances, okay, and we're going to scroll down to network and security, and we're going to choose security groups. Okay, and here's the security group we created. We want to make sure we select that one. Okay, and so make sure there's a check mark on it. And we're going to want to edit the inbound rules. So in the lower pane, we're going to choose the inbound rules tab, and we're going to create an inbound rule, add a rule that allows HTTP from any IPv4 address, and then we'll save the rules. Okay, so we're going to click on inbound rules. We're going to notice there's no inbound rules, right? So we're going to click on edit inbound rules. We're going to add a rule. And for type, we want to scroll down until we find HTTP. And then you know, right, by default, HTTP uses TCP port 80. Okay, the source is going to be any IPv4 address. Okay, now that is also represented by a quad 0 with a /0. So 0.0.0.0/0 in English means any IP address associated with any subnet mask. Okay, so these two mean the same. Any IPv4 and this quad 0 mean the same. You could have typed it in manually, but it's just as easier to select anywhere IPv4. And then we are going to save the rules. That's simple. Okay, and then we'll go back to our instructions, and then we'll test the rule. We'll refresh the page, and that should bring the lab complete. All right, so I go back to my browser tab, and This tab should be open for our web page. And let's hit refresh. And when you hit refresh, you get the hello world, right? Your website is operational, okay? Now we're hanging on to a public IP. So what we want to do is go back to the EC2 dashboard at the very top, okay? And where it says instances, we want to click on instances. And notice we got our web server instance. It's the only one. And then in the actions menu, okay, we want to go to, we want to go to instance state, and we want to select stop instance, okay? We just want to shut it down after you are no longer charged. See, notice the instruction here. After we stop it, we'll be no longer charged for usage or the data fees for it. But we don't have an elastic IP. However, if we had an elastic IP, we would still be charged. And if we created additional storage volumes, we would be charged. And we didn't do any of that. So we got an auto assign IP, not an elastic IP. We're good to go. You can click stop. Okay. And that will stop your instance. And then you're just going to leave the lab as is. And that successfully completes this lab. Okay. We'll pick up in the next lab. We'll create an AMI, a machine image. And from that image, we'll create our second instance. Okay. Take care.